Hi guys, let's do max area of island. So we're given an m by n binary matrix called grid, and an island is a group of ones representing land connected four directionally, horizontal or vertical. You may assume all four edges of the grid are surrounded by water. The area of an island is the number of cells with a value 1 in the island, and they want us to return the maximum area of an island in the grid. If there's no island, return 0. So given this grid in example 1, we would output 6 because, so if we look at all the islands here, there's 1, 2, 3, 4, 5, 6 islands, okay? And then each one, we have to look at the area. So this one has an area of 1, this one has an area of 4, as we can see. This one has 5, this one has 4, this one has 5, and this one has 6. So we take the one with the maximum area, which is this one with an area of 6, the dark orange one, and so we would return 6 because that's the maximum area out of all of the islands. So, and they clarify that the answer is not 11, so like we would not include this bottom part as part of this island because they have to be connected vertically or horizontally, not diagonally. That doesn't count. So in example 2, we're given this grid and we would output 0 because there's no land in here at all. So we just return an area, so the max area technically is 0. Okay, so in this one, so we're given a 2D array that represents our graph. So we can actually just use this directly. No need for hash map or anything because we will explore the neighbors through up and down and left and right by the coordinates. And we can just use this array itself as the graph because these ones and zeros are, well, I guess technically 0 is I guess, I don't know if you'd count that as a node or not, but you get what I mean. Like the elements are the nodes. So yeah, we can do it. So we can basically just traverse through the grid. And when we hit a 1, then we know we've hit land. And so we can do a search on all of this node's neighbors and keep track of the area as we go until we hit a 0 or are off the grid or something like that, and then we stop. And then we just want to update the maximum as we go. So to keep track of the visited nodes, because we don't want to revisit nodes again, and in this case, I'm not going to, because in number of islands, I just immediately, when we visited a node, I just changed the value to 0 to sync the land so that we wouldn't count it again. This time I'll do the other thing that I was saying, which is I will actually have a separate array to keep track of our visited nodes. So I'll make a Boolean array of the same size as grid to keep track of nodes we've already visited. So new Boolean. Okay, and that way, so we'll have false for not visited yet, and so this will start out as all false. In here, it'll be just like this, but instead of 1s and 0s, it'll all just say false. And as we visit them, we'll mark them as true for, to signify that we have visited it. So then we also want to keep track of our maximum area. So we'll start that out at 0, and we'll update it as we go, okay? And the reason I'm starting it at 0, you could really start it at anything 0 or negative. But it's just to make it a little bit simpler because at the end we need to return the maximum. If there's no island, we return 0. So if there's no maximum, if there's no island at all, then we'll just keep this at 0 and then return it like that at the end. So, okay, now we need to loop through our grid. So for I is 0, I is less than grid.length, I plus plus. And we'll do the same thing for j because we need to do rows and columns. Okay, grid at I dot length j plus plus. Okay, now we need to check if our current value is a 1 or not. Okay, so if it is a 1, then we'll want to explore that island to to calculate its area. So if grid at I at j is 1, and we actually also need another condition, which is that we haven't already visited this node before, because if we've already visited it, we don't want to do another DFS on it and end up with an endless loop. So, and visited at I and j is not true, so it's false, okay? If that's the case, then we will update our maximum to be the max between our previous max and a DFS on that node. Because, so like, if we're at 1 here, like this island has an area of 1. So like, let's say our maximum is currently 1, right? And then we're going down, we get to here. Then we'll update it with a maximum between our previous max, which is going to be 1, or a DFS on this node, which will return the area of this island once we're done, right? So in our DFS, we're going to need to pass in a few things here. We need I and j and our grid and visited, okay? And that's because, so I and j we need because when we do a DFS in here, we will need to, like, in order to even access the neighbors, okay? The neighbor, like, how do we find the neighbors? Well, like, basically it's whatever coordinate we're currently at plus 1 or minus 1, right, is going to be its neighbors. Like, if it's at 7, then 8 and 6 of the same row is its neighbors, or 1, like, in the same column is its neighbor, right, because it's vertical or horizontal. So that's how we are going to find the neighbors, is through I and j, so we need that. And then we need our grid because we need to know if the neighbor even is a 1 or a 0, or if it's like out of bounds or something, right? If it's like we've already reached the end. And we need visited because that's how we're going to exit our DFS, is when we find something that doesn't work anymore. So like we hit a 0 or something, right? Or it's out of bounds. Then, or we've already visited it before, sorry. Then that means we don't want to revisit it. And we will need to mark it as visited once we do visit it. Sorry, that was like a lot of words, but I hope that makes sense. So then we're going to do this for the entire grid, and then at the very end, we're just going to return our maximum that we found. And then now we can write our method for our DFS. So private int, because we're going to return an area here, right? So that we can actually take the max between it and the other max. DFS, okay, and then we're going to pass in int I, int j, int grid, and boolean visited. All right, and our base condition for when we need to exit, okay, is if we're out of bounds, so I is less than 0, or I is greater than or equal to grid.length, or j is less than 0, or j is greater than or equal to grid at I.length, or our current value that we're at our node is 0. So, or grid at I at j equals 0. Or lastly, visited at I at j equals true. Then we've already seen that node and we don't want to revisit it. Okay, so if this is true, we will return 0 because that node, like let's say we're at this 0, right? Then this 0 would have an area of 0 because it doesn't count towards the area of an island. So then we would return 0, okay? And then otherwise, if none of these conditions are true, then that means we do want to explore it. So we'll mark it as visited. So visited at I at j equals true, okay? And then we will return, so 1 for this node, okay? We'll add 1 for whatever current node we're at that meets the criteria, like let's say it's this. This has an area of 1, so we're going to add that to a DFS of all of its neighbors. So I plus 1, j, grid, visited, okay, and then plus DFS I minus 1, j, grid, visited, plus, and we will just do this with all of the neighbors. And that should be it. All right, perfect. So here, let me write this down here. So our time complexity is O of, I guess, okay, they write it like this, so I'm just gonna write it the same way, m times n, I guess. M is number of rows, n is number of columns in our grid. Okay, which, logically that makes sense, right? Because we have to loop through the entire grid no matter what, and visit every single element or node in this grid. And we also see that in the code here in our nested for loop, right? We are visiting every single node, traversing through. And if it's if this condition is true, then we will do our DFS, which basically, so we might not necessarily explore this grid in order because of our DFS, but we are just exploring every node once, because if we hit the same node again, we are not going to revisit it. So it's the same, like our time complexity is going to be the same as this grid here, the size of the grid. Okay, and our space complexity is the exact same thing, because, so if we take a look at our data structures here, first of all, we have this Boolean array visited, and this is the exact same size as our input, so that's already m times n off the bat. And that is our only data structure really, except for the call stack from our DFS. And the call stack in our DFS, so if we think about that, then worst case, okay, every single node in the grid will just be full of ones. And if that's the case, then we are basically just doing one really long DFS on the first node that we encounter and nothing else. And so the stack will have all m by n nodes in it at once until we reach the very end of our DFS, and then we will remove them all off of the stack. So does that make sense? Yeah, so that would be our worst case. But either way, it doesn't really matter because this is already m times n, so they just get added and then simplified to this basically. But yeah, that's it for this problem. Thank you guys for watching, and like and subscribe if you found this helpful. Bye!